Assalamu alaikum, boys and girls. How is everybody? Today we are going to discuss the worksheet that I sent you last time about moment and stability. You can see the worksheet on your screen. The first question says the total weight of the load and the wheelbarrow shown is 600 Newton. So this weight is shown by an arrow towards the bottom. It says 600 Newton. Pivot is at the center of the wheel. As you can see, question says what is the size of the force F? The force F is at the handle of the barrow. You can see it over here. Needed just to lift the loaded wheelbarrow. So how much force is required here? As you can see that this force, when it is applied upward, it produces a moment, anti-clockwise moment about this pivot. So we have to take the anti-clockwise moment equal to clockwise moment produced by the load. Using the principle of moments, anti-clockwise moment is equal to clockwise moment. The force F is producing anti-clockwise moment about pivot, and the weight 600 Newton of the wheelbarrow is producing clockwise moment about the pivot. So F will be multiplied by the perpendicular distance of F from the pivot. So that perpendicular distance is 70 centimeter plus 50 centimeter. That is 120 centimeter. So F multiplied by 120 centimeter is equal to 600 multiplied by 70 centimeter. 600 multiplied by 70 centimeter is equal to F multiplied by 120 centimeter. So using the principle of moments, you can make the calculation. So that force will be about 350 Newton. Second question says a diver of the weight 500 Newton. The diver is standing at the edge of the plank over here. Its weight is 500 Newton acting downward here. At the end of the springboard, that is 2 meters long and is fixed at point P. So point P is considered to be the pivot. Diver is standing at the edge of the springboard whose length is 20. So the diver is producing a clockwise moment about the pivot. So the moment produced by the diver's weight will be 500, the weight force multiplied by the perpendicular distance between the pivot and the weight of the diver. The center of the mass of the spring is at the center. So that will be at a distance of 1 meter from the pivot. The center of mass of the springboard acts here at the middle of the springboard. What is the total moment about P of the diver of the board? The springboard weight is 500. It is also acting downward. It is also producing a moment about P. The weight of the diver is also producing a moment about P. What is the total moment about point P of the diver and the board? Together, we will take the moment produced by the weight plus the moment produced by the weight of the springboard. The springboard's weight is 500 multiplied by the distance from the pivot, that is 1 meter. And the weight of the diver is 500 multiplied by 2. So 500 multiplied by 2 plus 500 multiplied by 1. That would be 500 multiplied by 2 is 1000 and 500 multiplied by 1 is 1500. Total will be 1000 plus 500, 1500 Newton meter. So both moments produced by the weight of the diver and the weight of the springboard will be added. But the weight of the springboard is acting here in the middle of the springboard. So that's why I have taken this distance 1 meter for the springboard. Number 3 says a student balances a non-uniform object on a pivot. To do this, a weight suspended near the left end of the object. Near the left end of the object, a weight is suspended here. What is the center of the mass? Actually, the center of the mass is the point where the whole mass or whole weight of the object acts. If the center of mass, is C, then we don't need to put this weight over here. Then this object is supposed to balance at C. If we are using this weight on the left side, it means the center is not at C. It is not at C. Just to counter the clockwise movement, we have added this weight. So its center of mass would be somewhere at B. To balance, if we place it on B, it will be balanced. Number 4, the diagram shows a uniform half-meter rule. Half-meter rule means its total length is 50 centimeter, balanced at its middle. So it's balanced at its middle. We have 25 centimeter on the left and 25 centimeter of the meter rule on the right. If it is balanced, that means clockwise movement is equal to anti-clockwise movement. Clockwise movement is equal to anti-clockwise movement because it is balanced. So what is the weight of the metal? Again, we have to use the principle of moments. So weight of the metal multiplied by 20 centimeter, that is producing clockwise moment, is equal to 100 into 15. So 100 into 15 is equal to W into 20. That will give you about 75 Newton. Number 5, a piece of uniform cord is suspended freely from a horizontal pin. At which of the points shown is the center of gravity? First of all, remember, center of gravity always lies below the point of suspension. A is the point of suspension. So the center of gravity lies below A. So it is obviously somewhere on B, C, and D. After that, you have to consider the concentration of the mass of this card. So if I consider B, so major part of the mass of the card is below B. We cannot consider B as the center. A definitely is not center. If I consider B, most of the material of the card is below B. So I cannot consider B as the center. So C is my option, because if I see on the right or left of the C, the the material of the card or the mass of the card is balanced, and below and above it is almost same. So C is its center of mass. Number 6 says the stability of a bus is tested by tilting it on a ramp. The diagram shows a bus that is just about to topple. Where is the center of the mass? So in that case, you have to draw the vertical lines downward, which represents the line of action of the weight of the bus. The weight of the bus is acting downward. So if I consider point D, the weight is downward. So that line passes through the base of the bus. If line of the weight is passing through the base of the bus, it means it is not toppling. The weight will bring it back to its horizontal position. If I consider C, the line of the weight of C is passing almost through the tires. So at this position, the line of weight is about to get out of the base. It is not out, but it is about to get out. If I draw a vertical line at B, it will be out of the base. So if B is the center, then the bus will definitely topple. But it is about to topple, so we consider C as the center of mass. If C is the center of the mass, if you draw the line, you see this line passes through the tire almost. So it is not toppling at the moment. It is about to topple. It means line of weight is passing through the tires almost. So C is its center of mass. We have to always draw the vertical lines from point D, C, B, and A. And we have to consider which line is falling outside the base of the bus. So if I draw a line from B, it definitely vertical line falls outside the base. So it will topple the bus down. But because the bus is not toppling at the moment, it is about to topple, so we consider C as the center. So my option is C. What affects the stability of an object? What affects the stability of an object? You people don't know the area of the base affects it and the height of the center of the gravity from the ground. Only base area, only its base area and the location of the center of the mass, only its weight and the base area, only location of center. The B is my option. There are two physical quantities which affects the stability. One is the base area and one is the location of the center of mass or center of gravity. So B is my option. A uniform meter rule is balanced at 4 Newton by a 4 Newton weight as shown in the diagram. 4 Newton weight is acting here at a distance of 10 centimeter from the pivot. So the perpendicular distance between the pivot and 4 Newton weight is just 10 centimeter. Weight of the meter rule acts at the center of the meter rule. So weight is acting at a 50 centimeter mark. So the distance between the pivot and the weight is 40 centimeter. 50, 10 centimeter we have on the left. So we have 40 centimeter on the right of the pivot. So again we have, because it is balanced, so we have to use principle of moments. W multiplied by 40 is equal to 4 multiplied by 10. So the weight, if you calculate W multiplied by 40 is equal to 4 multiplied by 10, the answer would be 1 Newton. Number 9 says a metal cone with a circular base is placed on a flat surface. The stability of the cone depends on, you already know stability depends on two things. One is the base area and secondly the location of the center of mass. So we can say that the diameter of its base, the diameter definitely affects the size of the base and the position of center of mass. So B is my option. Number 10 says the 4 solid uniform cones have equal weight. Their weight is equal. They are placed on a bench as shown in the scale diagram. Which cone is the most stable? So we have to consider two things: the base area. C has the maximum base area, and secondly the location of center of mass. So C has the lowest center of mass. So C is my option. In other cases, the center of mass is slightly above the center of mass of C. If you just locate a center position, just geometrical center of these figures will be center of mass. So C is my option in this case. Number 11 says an object Y is in a fixed position on a rod. A weight X is moved and the position of the pivot is adjusted until the rod balances on the pivot. We have balanced the rod on the pivot by adjusting the position of